Today we're going to be looking at multiplying polynomials. So that's why we had to take a little sidestep and learn about all those properties of powers when it came to exponents. We initially started with adding and subtracting. We were working our way to multiplying, but had to take that quick pit stop. So we're back at it now, and we're going to jump right in. I got a couple different methods of how to do these problems, different ways I'll show you today, but they look very similar. So let's say we had 3x plus 2 and 8x minus 1. Now previously we had two sets of parentheses before. Each of these polynomials, like the first one has two terms, it's a binomial. The second one has two terms, also a binomial. But previously there was either an adding sign or subtracting sign in between. This time the two parentheses are touching, meaning that we are multiplying. Now maybe in the past you've learned this method, and I'm going to start with this and then switch to something else, but when we're multiplying these polynomials out and there's two terms in each, see, two terms and two terms, we could use what is called FOIL. All right, and FOIL is an acronym that stands for firsts, outsides, insides, and lasts, and those words represent what we're going to multiply together in a certain pattern. All right, and this will be the last time I do it because this is a little bit outdated method now. So what we do is multiply the firsts together, so the first in each parenthesis. So 3x times 8x, because this is multiplying. So 3x times 8x, so 3 times 8 is 24, x to the 1 times x to the 1. Remember, if we're multiplying two things with the same base, we add the exponents. So it's 24x, 1 and 1 make 2, adding. So that's the first. Now let's multiply the outsides. So I'll switch colors here. So now the outside ones are 3x and negative 1. So 3x times negative 1 is a negative 3x. All right, so far so good. Let's move on. Now let's do the insides. Multiply the two inside ones. 2 times 8x. So that's a positive 16x. And finally, we're going to multiply the last together. So that's the 2 and the negative 1, negative 2. And we're almost there. It looks almost standard form, except we need to add or subtract these two together, combine them. So the 24x squared has nothing to go with it, so we'll write that down. The negative 3 and the positive 16 combine together to become a positive 13x. No changing the exponents here because we're adding and subtracting. And then a negative 2 at the end. And we check nothing else combines together. That is our final answer for multiplying these two polynomials together. All right, let's take a look at another one. Let's say we have 8x minus 8 and 2x minus 6. All right, again, it's two binomials being multiplied together because those two parentheses are touching. That's a multiplication problem. This time I'm not going to use FOIL. I'm going to use something that maybe helps us out a little bit more in future problems. So I've got a 2 by 2. So I'm going to create a 2 by 2 table here. And I'm going to write the first one on top, each term on top of a column. So the 8x here, and the next piece is negative 8. So I'll write that right there. I'm going to write the other polynomial up and down, so a 2x and a negative 6. And what I'm going to do is multiply it piece by piece. It's almost the same pattern, but this just looks a little bit cleaner to us. So I'm going to multiply, and follow with me here. 8x times 2x, and that answer is going to go in that first box here. So 8x times 2x is a 16. x1 times x1 is x squared. And you can really move to any box that you want. I'm going to go ahead and move next to it. I want negative 8 times 2x. That answer is going to go here. That's a negative 16x. And we just keep moving around, and we're just matching up this as a grid. So 8x times negative 6 goes down here. That's a negative 48x. And finally, negative 8 times negative 6 goes down here and makes a positive 48. So just like last time, we came out with 4 things, 4 pieces, and now let's look throughout the whole thing and combine like terms. So I'm only looking at the pieces inside the box now. Pieces inside the box. The biggest exponent is the 16x squared. So I'm going to write that first because we want this in standard form, and there's nothing else to go with it, so that's done. The next biggest exponent is x to the 1. There's a negative 16x and a negative 48x. So if they're both negative, that really means we're going to add them together, but keep the answer negative. So we have a negative 16 and a negative 48. Those combine together to become a negative 64x. And then, see those combine, and then finally a 48 at the end, which comes out to a positive 48. So we've combined like terms, and there we go. It's in standard form. Okay. Practice makes perfect, so here we go. 5m plus 10 and 2m minus 4. So anytime we see these two being multiplied to each other, we can create that same amount, so a 2 by 2 table here. I'll write the first one across. So 5m and positive 10. If it helps you to write that positive sign, go ahead. Over here we have 2m and a negative 4. And let's multiply and match. 5m times 2m, 10m squared. 10 times 2m is going to be a 20m. 5m times negative 4, negative 20m. And then 10 times negative 4 is a negative 40. Again, we've got these 4 terms, and if you notice from the last one, everything diagonally will match. So for example, anything in this row goes together, anything in this row goes together, and then these go together. So really it's just the ones with those single m's go together. All right, so writing this out, the 10m squared has nothing to go with it, so 10m squared. The negative 40 has nothing to go with it, but we do have the 20m and the negative 20m, so these two go together. They're like terms. But a positive and a negative 20 cancel each other out, so actually they're gone. And the only thing left now is the negative 40. So in this case, we went from 4 terms to now 2 terms because the 2 in the middle canceled out. And one last problem for now. And you'll notice why I switched away from FOIL to this other method, this box method. 3n minus 11 and 5n squared minus 4n plus 8. So interesting here. We've got a binomial and a trinomial, a 2-term times a 3-term. For FOIL, the word FOIL, you only can do first, outside, inside, last, but now we've got extra things. It's a lot of lines to be drawn to multiply this out. But let's still use the box method. This time it's a 2 by 3. So I'm going to go ahead and draw more to the side. So we've got 3 boxes side to side and 2 up and down. Okay, so let's match it up. So I'm going to actually put the 3n and negative 11 over here. Remember, the order really doesn't matter where you put it. And then on top, we've got the 5n squared, the negative 4n, and then the positive 8. Okay, but we're going to still follow the grids and multiply all this out. So 5n squared and 3n is a 15. n1 and n2 make n3. Negative 4n and 3n make a negative 12n squared. And then 8 times that 3n gives me a 24n. Now let's go ahead and quickly take this negative 11 times all of those. So 5n squared times negative 11 is a negative 55n squared. Negative 4n times negative 11 is a positive 44n. And then positive 8 times negative 11 is a negative 88. And remember, the pattern here is all the diagonals go together. So this, these, and this. So the first and the last are really on their own, but then the in-betweens go together. That's just the quick way to remember which like terms go together. So I like to start with the biggest one, so n cubed. So 15n cubed, that's it. Let's combine a negative 55 and a negative 12. That comes out to a negative 67n, and now we don't change it because we're adding and subtracting. Only when we're multiplying we change the exponent. Plus a 44 and a 24 make a 68. And we keep it. And then finally the negative 88 at the end. So use whatever method is best for you, whether it's FOIL or this box method. The box seems to work out once there's more terms, but either way, you come out to the same answer.